Today we're answering a question that confuses a lot of students. How do you handle significant figures when adding or subtracting whole numbers? Let's break it down step by step. Normally, when adding or subtracting, your answer should have the same number of decimal places as the least precise number in the problem. Now that's simple until we use whole numbers with no decimals, like 200 or 58. Let's look at 200 plus 58. So the math says that 200 plus 58 would equal 258. But in chemistry, we have to ask, how precise are those numbers? What are we confident in? So I'm going to first show you a quick trick for how to find this answer with the proper sig figs, and then we will get into the more detailed reasoning behind it. So we are going to start by drawing straight lines down from each zero until you hit the first non-zero digit. Now, whatever that non-zero digit is, that's the last place that you're confident in. Everything to the right of that will get rounded off. So for 200 plus 58, it equals 258 like we said. We're going to draw those lines down from the zeros in 200. So this is a zero. We're going to just draw it all the way down. And this is a zero. And then we hit the 2, which is the first non-zero digit. So we stop. So they stop at the 2 in the hundredths place. And this is going to tell us that our answer must be rounded to the hundredths place, which in this case, a 5 will round a 2 to a 3, and this answer with the proper sig figs is 300. Now let's get into the more specific reasoning behind this. So when we write 200, what we're really saying is that this value was rounded to the hundredths place. And this is because the true value could have been anywhere from 150 to 249 before it was rounded. We don't know exactly where it was rounded from. It might have been 150 or 206 or 249, but we know that the rounding happened at the hundredths place. But why do we say that the 2 is significant here if some of the possible numbers, like 150 through 199, actually start with a 1? Here's the key idea. The 2 is significant not because it's guaranteed to represent the exact first digit of the true value, but because it tells us the scale we're confident in, which in this case is the hundreds range. That's what a significant digit really means. It's the last digit we have a reasonable confidence in before uncertainty takes over. So in 200, the 2 is really saying, I'm sure this number is in the hundreds. It's roughly 200 something, but I'm not sure about the tens or the ones place. The zeros after it just mark the place value. They are not measured or known values. So just as a recap, the 2 is significant and it determines the range of certainty, which in this case is the hundreds. And the zeros are not significant. They're just placeholders that show we rounded off everything smaller. Now let's go ahead and look at 58. So if we wrote down 58, we can see that we are confident to the ones place. And this is because, again, it could have been rounded from any of these values, which is a lot. But that only has a small uncertainty because you can see here that it's the tenths place that is rounded. So this means that both the digits, the 5 and the 8, are significant. So when we add 200 plus 58, we are combining a number, 200, which is only certain to the hundredths place, with the number 58, that is only certain to the ones place. Now remember, when you add them, your final answer cannot be more precise than your least precise number. And 200 is a much less precise number, which is confidence in the hundreds versus confidence in the ones. So instead of writing 258 as the answer, we have to take sig figs into account, and we are going to round to the hundredths place, which keeps that same level of uncertainty. And this again gives us 300 as the proper answer with the correct number of significant figures. If this helped clear up your sig fig confusion, please hit that like button and subscribe for more bite-sized chemistry lessons. and let me know in the comments what topic you'd like me to cover next. Thank you.